So I came back to new connection. Shall I refresh once? Good morning all. Sorry, good evening all. Good evening Ravi, Sagar, Harsh, Udit, Aishwar, Vivek, Rudraksh, Asif, Shubham, Ruchita, Rishi, Aditya, Suraj, Sriram, Ganesh, good evening. Danpal, Anuj, Aditya, Kronal, Eddie, Matthew, maybe Subra. Good evening, Hrithik. Times the net issue came na, maybe only. I mean, the new we take more time. We spend more time on this. So because one class is cancelled, I extended one last 30% of your total time we are allocating will be more around 20 to 30% of the time we are giving to this chapter. It's not toughest. Okay, once our discussion is done, you feel comfortable. Don't worry. If you attend all my classes, you never feel any difficulty. Nothing prerequisite is required. In our class, you sit. I teach you from the basics. Okay, we discuss from the basics. Very zero level. You know what is gate, that is sufficient. What is NAND gate, what is NOR gate. If you know what is NAND gate, NOR gate, sufficient. Remaining, I will take care. Okay, so let's see. So the first one we are going to discuss is the flip-flops. I think from 2 days you are behaving differently. Something happened. Yesterday some COVID also came. Where is he? We don't know he or she, but even if but complete the previous parts. Previous 3 chapters I have completed in the part 1. Combinational circuits, Boolean algebra. What is that? Number systems are completed in the first part. So those who are new, completely new to the class, please go through that. Okay. But that is not a prerequisite here. Mostly you will be able to understand. Ashish, good evening. So let's start. So the first point we are going to discuss is flip-flop. What is flip-flop? Flip-flop is a basic memory element which can store 1 bit of data. Everybody will say flip-flop will store 1 bit of data. We will prove it also. Don't worry about it. It contains 2 outputs which are complementary to each other. This is another fundamental requirement of the flip-flop because in the applications I will show you it's a need. Next, since it will have 2 stable states. That's why it is also called bistable multivibrator circuit. It is used in many applications. We prove all the applications once we discuss clearly. Bharati, good evening. Okay, frequency division, key debouncing. What is this, sir? Don't worry now. I will explain it. Don't worry. Latch is level triggered, flip-flop is edge triggered. Okay, leave it. What is level triggering? What is edge triggering? Everything we discuss in the coming. Okay, for timing, don't worry about it much. So I will prove all the points here. So before going to the flip-flop, let's have a look here. Multi-vibrator. Okay, so if you give 0 here, it will be stored as 0. If you give 1 here, it will 1 is 0 locked to 1. Only first 2 slides, don't worry, continue. Okay, so these are locking the data. These 2 circuits you observe, it is locking the data. Yes or no? I am having 0, it is locked with 0. If you have 1, it is locked with 1. Lock, or it is called latching the data. What is this? Latching. Okay. Just English meaning, nothing to worry about. Latching or retaining. We are in the beginning only, don't worry. Retaining, storing, okay, or locking. Okay. So you can use any one of this terminology. Data. What it is doing, it is locking, storing, latching, whatever may be, retaining the data as it is. So one drawback here is you want it, if it is at 0, it will be at 0. If it is at 1, it will be 1. But here we cannot give input. Okay, or we need to open feedback to apply input. Everybody accept this or not? Say I want to store, it is at 0, I want to store 1. What I need to do is this wire should be opened and keep 1, and you need to close. Some kind of process is to be applied, because one output and one input are getting connected here. Okay, this feedback line is to be opened, then you may be applying the input and again connecting back is the required. Okay, it is every time it is not feasible to open the wire and close the wire. Okay, so if I have some kind of switch here which can do this job, it is not a physical switch. If there is a digital switch, that is, it can be like multiplexer circuit, or it can be some kind of another gate, then it will be more advantage for us. Okay, I need, without opening this wire, if I am able to do it, then it will be more advantage. So how to do that? Let's see that. Okay, is it clear? This is the basic circuit which we use in the latch. That's why I'm explaining it you more clearly. Okay, so now let's move to the first part, that is SR latch. It is also called as SC latch also. Here C for clear, here S for set, and R for reset. Reset or clear you can call. Okay, SC latch is not a new latch, it is same as SR latch only. Okay, so in that, let's have two versions. First one is using NOR gates. Okay, let me do it. So this is the circuit of SR NOR latch using NOR gates. What I am doing is using NAND I have taken. Okay, don't worry. Let me upload NOR. We can discuss both. Okay. You can understand, Madhuri, how many slides it can be, but try to follow from now. It will be helpful. Don't worry. Using NOR. Okay. So let me load all the slides so that you can save. We can save the time. Just before your class, 2 minutes before only, I draw these figures and take the screenshots. That's why I joined little early today. I'm just uploading, just wait. Huh. If any issue is there, just tell me. One minute. Shall I continue? So as I told you, as I promised you, when I discuss the sequential circuits, I will give you very basic feel. Let's see how much basic we'll be able to discuss here. Now, please listen. Please listen. I will discuss this much basic onwards. What is NOR gate onwards? Okay, for NOR gate, if you apply one of the input as 0, one of the input as 0, other input can be anything. What is the answer? Sorry, 1 minute. 1 minute, 1 minute. One of the input is 0. Okay, let me keep A here. 0 plus A. What is the answer? 0 plus A is A bar. It is like a inverter. Next, if you take another NOR gate, make one of the input 1. Other input can be anything. 1 plus anything is 1. Whole bar is how much? 0. We call this as disable input. Okay, here I will give you one important note. Always start your analysis with analysis from a gate with disable input. It is easy, that is the reason. Okay, because if you have disable input, what is disable input? 1. If NOR gate is having any one of the input as 1, no need to analyze the second input. That will make your analysis very easy. No confusion will come. So always start your analysis from a gate with disable input. If no disable input, okay, or 1 minute. This is the basic class of sequential circuits. Very, very, very important. Please concentrate. Today we may not be discussing even maybe 1 or 2 problems only, hardly. But this concept is helpful throughout the entire course of the sequential. Please carefully understand. I'm taking, that's why I'm going little slow also. If no gate is having disable input, then if no gate is having disable input, then we can analyze from any gate. Okay, this is the fundamental to the analysis. So always make your analysis to start from the disable input. Okay. Now let us do the analysis using the NOR gate. For NOR gate, S and R can be 0, 0, 0, 1, 1, 0, 1, 1. Different cases are possible. Will you accept it or not? Okay. So let me start with S equal to 1, R equal to 1. Always start your analysis from a gate with disable input. Is it clear? NOR gate mein what is the disable input? 1. For example, I am taking all cases here now when s equal to 1 1, s equal to 0 0, everything. So let me I want to find the truth table of this SR. That is my intention. Okay, so please listen. Shall I change the network? Okay, 1 minute. Let me check the connection. Okay. 1 minute, 1 minute. I think the issue is with the internet connection. If you have, if it is not fine, just tell me. I can change the connection. We have second connection, second alternative also, no problem. So tell me if it is okay, fine. Otherwise, we can change the connection. We have two connections now. Is it lagging? So let me change the connection. Don't worry. So I came back to new connection. Shall I refresh once? Okay, we came to new connection. Don't worry. I hope it is fine now. So let's go back. If one of the input to the NOR gate is 1, if one of the input to the NOR gate is 1, no, it is just refreshed. If one of the input to the NOR gate is 1, other input can be anything. Is it audible? Okay, okay. So, okay, now listen here. This is the important point which will make very comfortable in your latches and flip-flops. So one of the input to the NOR gate is 1, other input can be anything. One of the input to the NOR gate is 1, other input can be anything. Your output is always equal to 0 because 1 plus anything is 1, whole bar is always equal to 0. So I want to analyze this NOR gate when s equal to 0, r equal to 0, s equal to 0, r equal to 1, all cases. Okay, this is what we call SR NOR latch. It is nothing but, please see, you see this figure? Can I draw this figure like this or not? Can I draw this figure like this? Yes or no? Acceptable or not? Only same figure I used, but now instead of inverter, I used NOR gates. Instead of inverters, what I used? NOR gates. S, R, here Q, Q bar. In the SR NOR latch, that S will come in the bottom. Reason, everything will be explained. Just keep some patience with you. Okay. Right. So I have taken two cases. What are these two cases, sir? Tell me, yaar. What are these two cases? Initially, your output is 1. Initially, your output is 0. Okay. Sorry. Initially, your Q is 1. Q bar is 0. Initially, Q is 0. Q bar is 1. What is the meaning of initial, sir? By the time you have applied the inputs S and R, before applying this S and R, already some values may be present at Q and Q bar. They may be 0, 1, 1, 0, 0, 0, 1, 1, anything. Okay. We just assumed these values as 1, 0 one time, and another time we analyze that 0, 1. Is it okay, everybody? Now, I want to analyze how this circuit will work when S equal to 0, R equal to 0. That is when S is equal to 0, R equal to 0. You tell me, is there any disable input to the gate? Only tell me about S and R. Only tell me about S and R. Forget about this part. Only tell me about SR. There is no disable input. Then you should analyze in your way. Okay. So here you understand, when one of the input to the NOR gate is 0, what is this? Tell me, inverter. You have accepted. So please listen here. If this line is 0, if this line is 0, it will act like inverter. Na 0 bar will come here. What is 0 bar? 1. This 1 will come here. Because it is an inverter, 1 bar is how much? 1 bar is how much? Okay, I'm repeating this. Okay, don't comment for some time because it will avoid confusion of your friends. So just for 1 minute, don't comment. I mean, up to end of this. After that, you can comment happily. Just listen. I am taking S equal to 0, R equal to 0 are my inputs. Q bar can be any value. I just assumed as 1, 0 and also 0, 1 initially. Two cases I'm analyzing. Because there is no disable input, blindly analyze from any point of your wish. Nothing wrong. Okay. I assumed initially 1, 0 na. So because both of them are just like inverters only, is it the same figure or not? Two inverters connected back to back. When S is equal to 0, R equal to 0, it is nothing but two inverters connected back to back. Because when S one of the input to the NOR gate is 0, it will work like an inverter. We know that. Okay. So by using that concept, if this 0 comes here, 0's inverter is 1. 1 will come here. 1 inversion is 0 will come here. That is, it is earlier 1, 0. Now also it is 1, 0. Just leave it for some time. Now come here. Now come here. Already if it is 0, 1, what happens, sir? See, same way. Take this one here. 1 inversion is 0. 0 comes here. 0 inversion is 1. Now, you can start commenting if you have any kind of doubts. Now onwards. Now listen here. Okay. At any here, both the cases, what is the observation? Tell me. Tell me. Both the cases, what is the answer you are getting? It is already 1, 0, you are getting 1, 0. Already 0, 1, you are getting 0, 1. What does it means? It is called as output same as input, or this is the case which is same as two inverters connected back to back. Okay, so this case can be written as Qn plus 1. Output in the next state is the same as previous state. We call this as latch condition, hold condition, or storing the data. Is it acceptable for everybody? Any doubt, please ask. Rohit, what is your doubt? When Q bar equal to 1, another NOR gate will act as, yeah, you can analyze like that also. But we are not worrying about this. You can take like that. One of them is a disable input, other can be anything. You take it as 0 and start the analysis, you get the same. Is it clear, everybody? Any kind of doubt, please ask me. I am doing the analysis easily. Yeah, this is the next state you will be getting. No, not reverse, not correct. Sushil, I will tell you the reason. Just wait for some time. You should keep like that only. So shall I move further? Okay. So let me analyze. Suppose. Yes, Rohit. But you should not consider disable as these things because they may change. So you should not consider these inputs and say disable enable. Always say disable enable with yes and r only. Don't worry about these values because these are constant, not constants. They may change. So we analyze the with respect to yes or always, not with respect to the previous values. So let me start the analysis. So here, for example, I want to analyze when s equal to 0, r is equal to 1. So let me start with s equal to 0, r equal to 1. Here also, I will analyze the two cases. What are they? When q0 are initially q0 and initially q1, both the cases. But you have disable input here. What is the disable input here? 1 is the disable input. Now you see, you please listen carefully, observe. If one of the input to the NOR gate is 1, this is what we call disable. Other can be anything, doesn't matter. 1 plus anything is 1, whole bar is 0. That 0 will come because one of the input is 0, it will act like an inverter, 0 bar will come 1. Just wait. Here also, when S is 0, R is 1, one of the input is 1, other can be anything, it doesn't matter. Other can be anything. Okay, that is here you have 0 or 1, it doesn't matter. 1 plus anything is 1, whole bar will give you 0 only. That 0 will come, 0 bar will give you 1. Maybe initially some only 1 may change, then second may change depending on the delays. But what I am giving is a steady state final values only. This process may take different delays, will take different outputs. So don't worry about it. We are speaking about the final output. So now what is the answer? In both the cases, what is the answer? You should not say it is not changing because it should be correct for both the cases. What is correct for both the cases? In both the cases, at any cost, it is giving me as q equal to yes, qn1 is equal to 0. We call it as reset. Yes or no? Okay. It is more meaningful. Now you observe s equal to 0, r equal to 1. R equal to 1 means what? It is giving reset in the output. Reset means 0. Is this clear? Shall I move further? Can I tell you one thing now? Can I tell you one thing? Whenever this cross comes, what is the meaning of it? Whenever this cross comes, what is the meaning of it? This value can be anything. What does it mean? Here you need not worry about previous value. Is it clear? Previous value can be anything. This fellow will not worry about it. Immediately he will give 0. So here actually you need not worry what is the initial previous value. Your answer will not be dependent on the previous value. What is the meaning of this cross? Output does not depend on previous or initial value. Okay, that can be anything, it doesn't matter. Initially 0, 1 or 1, 0, its performance is same. Okay, what is qn plus 1 is this value. What is this value? After applying your input, what is your value? Finally, how much you are getting in both the cases? In both the cases, Abhijit, what you are getting? 0. That's what I write. 0 name is reset. 1 name is set. Shall I proceed further? अरे यार, why this not NAND gate is coming? Okay, now listen. Let's analyze one more case. That is when S equal to 1, R equal to 0. That is S equal to 1, R equal to 0. Initially, whatever you have, you know, where is the disable input, man? Now you understand how easy is your analysis. S is having disable input, so other input can be anything. Other input can be anything. 1 plus anything is what? 1. Whole bar is 0. So initial value doesn't matter for me. Initially 0, 1 or 1, 0 doesn't matter. Immediately I get 0 here. That 0 will come. 0. It is like an inverter. 0 bar is 1. I am repeating this again. Please see. I applied S equal to 1, R equal to 0. When one of the input is 1 to the NOR gate, don't analyze the second input. Second input is nothing but already existing value. It is connected like a feedback here. Okay. So this value can be anything. You just take it as 0 or 1, doesn't matter. It is just assumption. Okay. It can be anything. It can be anything. 1 plus anything is 1. Whole bar will give you 0. It is not Q bar, Nishita. It is 1 because it is not depending on the previous value. Na? It will not, suppose initially 1 0, then also you get 1 0. Initially 0 1, then also you are getting 1 0. Okay. Yes. So please listen, as Nishita told, okay, never take that kind of conclusion. Some people may do it. Sir, here can I say no change? Here can I say it is a toggling or Q bar? No. You should take both the cases, then justify your answer. In both the cases, your answer is 0 1. Similarly, here whatever may be the previous value, whether it is 0 1 or 1 0, both the cases, what you get? What you get? 1 0. So here you can say Qn plus 1 is equal to 1. That is what we call set. That is what we call set. Strike off this fellow. Lastly, S equal to 1, R equal to 1. Okay. What is your doubt, Krishna? We are going when S equal to 1, R equal to 0. Next week, we analyze when S equal to 1, R equal to 1. What is the problem? Any doubt, Krishna? Why Q bar is one man, you forget NOR gate or what? After studying 3 chapters, you forget how NOR gate works? 1 plus anything, what is the answer? 1. Whole bar is how much? 0, na? This 0 will come. 0 plus 0 is 0. Whole bar is 1. Initially, there is 1. Whatever you have, what is the problem? So, you want, initially you take 1 here. If you analyze like that, you end up with confusion only. That's why I told one proper method, you follow that. Otherwise, these sequential circuits will be confusing for you forever. Let me explain you again. See here, if you take here initially 1, 0 plus 1 is how much, man? Tell me. 0 plus 1 is 1. Whole bar is 0. Okay. Then this 0 will come here. Whatever may be, 1 plus 0 is how much? 1. Whole bar is how much? 0. That 0 will change here. Na? Again 0 plus 0 is 0. Whole bar is 1. So if I explain like this, you end up with confusion only. That is not our style. That is not our style. Okay. So here easiest way to analyze is when one of the input is 1, other input can be anything. Here whatever it is there, finally it should become 0. Maybe initially 1, doesn't matter, but finally it should become 0. Na? Then this 0 will come here. Now whatever may be initially, finally this 0 will come here. Then 0 plus 0 is 0. Whole bar is 1. Is it clear? We are talking about the final values. That's why it will be always easy if you start with the gate with disable input. Because if one of the input one, you need not analyze this input. That is, whether it is changing, not changing, it will not affect your answer. Is it okay? Okay. Now see here. S equal to 1, last one, R equal to 1. So tell me when S equal to 1, R equal to 1, initially anything, it doesn't matter, it's a dummy, initial can be anything. 1 plus anything is 1, whole bar is how much? 0. 1 plus anything is 1, whole bar is 0. Both will become 0 here. Both will reset. Okay. When this cross comes, you understand it can be anything. Okay. This is what we call invalid state. Why invalid, sir? Because Q bar should be complementary to each other. In the design, we see its importance later in the registers, counters, etc. Okay. But these are equal here now, so it is not a valid condition. Q bar should be complementary to each other, but they are coming same, so I should avoid that. So go back, next. Don't worry, I mean, I have loaded extra. So now let me fill this table. 0, 0, 0, 1, 1, 0, 1, 1. Okay, you tell me. First, S0, R0 output same as previous value. Qn bar. Okay. When S0, R1, S is 0, R1, output is 0 and 1. When S1, R0, output is 1, 0. When a 1, 1, output is 0, 0. Now let us give names for this. This is what we call no change. Change nahi hai hamare paas. Okay. Or you can say it is. Okay. No change. When I see this, I can say one line. Change. You know this? One should bring their own change. Right? So who will say this? Change cannot be given. Change should be brought by you. Yes, bus conductors generally say this. Okay, so no change ka matlab here it is not that change. Here it is, it will not change. It will be in the previous value. Okay, so no change or hold or latch condition you can say. That's why it is called latch. You understand now it is why it is called latch? Because it is holding the data. Next. This is 0. You talk only Q. Forget about Q bar. If you take only Q, okay, it is called reset. If you take Q equal to 1, it is called set. Both are 0, it is invalid. Now you understand why I take S in the bottom, R in the top. Why I take S in the bottom, R in the top? It will be more meaningful. How more meaningful, sir? When S is 1, it is giving set. When R is 1, it is giving reset. You understand or not? Your truth table will be more meaningful if you take S in the bottom, R in the top. Otherwise, it will not be more meaningful. Even though you get some similar table, but it will not be much meaningful. That's the reason we take S equal to bottom, R in the top. Okay, now I hope everybody understands the yes or nor latch. Yes or no? Any single doubt, please ask. Happily, I can explain you. Yes, Harshvardhan. What is the last point I told you? Invalid. Why it is invalid is Q bar should be different. Nah, they should be complementary to each other. But Q bar same. Is it a valid condition? Tell me. Q, Q bar should be complementary to each other, but they are same means it is invalid. Right. Okay. Any other doubt? Now you understand. Is it easy way to analyze your latch or not? Q bar, X and X bar. If X is equal to 0, X bar should be 1 man. If X is 1, X bar should be 0. But if I get both the same, it is of no meaning. That's why I said it is invalid, illegal. Okay? Right. So, when both 0, it is not changing. Please see here, Udit. When both 0, it is nothing but when one, you should remember this in your mind. That's what I told Aditya. You cannot interchange. You can interchange, okay? You can interchange, but you should interchange S and R also in that case. You want to change interchange Q and Q bar, okay? Interchange S and R also. Then only you get to proper meaning. Okay, where is that? Udit, please see. You should keep these two in your mind. When one of the input is 0, this fellow will act like an inverter. One of the input is 1, this fellow will work like a output is equal to 0. We call it as a disable condition. Now see, if S and R are there, when one of the input is 0, they are like a inverters. Both are inverters only. Okay, initially 1 0 is there. This you start analysis from anywhere, you end up with the same answer. This 0 will come here, then 0 bar will come here 1, that 1 will come here, 1 bar will come here 0. Just you assume these two are inverters only. So you understand, we are doing the same inverter circuit with extra control in your hand. Udit, right. Now listen, how to store data in the flip-flop, sorry, data in the latch, simple logic. You want to store 0, what to do? You want to store 0, give S0 or 1. Then this Q will become 0 automatically. Then make it 0 0. Then it will not change. It will keep that 0 1 as it is. Similarly, you want to store 1 na, then give 1 0 in the input. Then what is the output you get? 1 0. Then make it 0 0. It will not change. Okay, make it 0 0. It will not change. Right? So let's move further. This is the ideal case. We are not expecting any noise to occur and all. So let's move further. So now come to the next state. If S equal to 1, R equal to 1, but 1 minute. Okay, here 1 minute please. Yeah, for 1 bit, 1 latch is sufficient. Please listen here. When S is 0, R is 0. Okay, and initially you have 1 1. Initially 1 1. What is 1 1? Invalid. Okay, so this may be possible. Now we should analyze this line also. Okay, I have analyzed this. I am waiting for you people to ask me this question. Sir, why you analyze initially 0 1 1 0 only? Why not it is 1 1? We should analyze this also, na sir? Right? So if this is the case, I applied S0 R0, what happens? We should understand this. Let me analyze this part also. Right. So here I will analyze two cases. One case is any one of the gate is having more propagation delay. Okay, please understand. If you have this don't care condition, it doesn't matter. Initially, valid condition is there, invalid condition is there. It doesn't matter because one of the input is 1. It never worry about the previous value. Simply, you will get 0. This problem of analysis will come. Invalid state analysis is required when both are zeros because there is no disable input here. Here, your output is depending on the previous inputs. So, if by chance, somehow it is not 0, 1 or 1, 0, suppose if it is 1, 1, what happens? Okay, or if it is 0, 0, what happens? Let's do this analysis. If please listen, we are assuming input is constant and analyzing. If input changes, accordingly your output changes. That's what I'm saying. So there is a chance by noise or some reason, if I am taking the condition, if this happens, how your system works, we should know this or not. You want to know it or you don't want? It will not happen, sir. I don't want to know, then I can leave. We need to know it or not. Yes. So let's do the analysis. Let me take this gate TZ1 or okay. Let me take this gate is having a propagation delay of 1 and this is a TPD2. So let me take the first condition. If propagation delay of first gate is less compared to second gate. First gate is having less delay, means first gate will move or change little faster than second gate. Then this one will come here. First gate is having less delay, na? This fellow is a little hurry to change. 0 plus 1 is 1, whole bar is 0. This 0 will come here. 0 plus 0 is 0. Whole bar is how much? 1. Let me analyze second case. If TPD1 and TPD2, I want to analyze if TPD1 is greater than TPD2. Now, who is faster? Second gate is having faster. Second gate is having more enthusiasm to change. Okay, it is a quick, hyperactive compared to your first gate. Now, what happens? This 1 will come here. Okay, 1 plus anything is 1. Whole bar is 0. This 0 will come here. Already maybe 1 is there. Okay, don't worry about it. Now, steady state, I am saying 0 plus 0 is 0. Whole bar is. Maybe this 1 initially present. 0 plus 1 is 1. Whole bar 0. Internally, in intermediate, okay, hazards may occur. I am saying only steady state. Final values only I am speaking. So, it depends on which gate is having more propagation delay, that will win. If it is having less propagation delay, this fellow will get 0. If it is having less propagation delay, this fellow will get 0. Yeah, I will explain. Definitely, Aman, don't worry. If both are having same propagation delay, then also we will explain that. I will explain that also next. Don't worry. I don't leave you like that. Firstly, this point is clear, then I will move further. What is your doubt, Ganguly? Please ask me clearly. I can explain. Don't worry. Okay, don't see the total figure at a time. You never understand in the sequential. Step-by-step analysis is required. So in the first case, how I analyzed, this fellow is having less delay. So this fellow will change first. That is my analysis. Okay. So first case, I have analyzed this first and this second. But the second case, I analyzed this gate first and this gate second. Now you observe, initially 1, 1. Now first I started with this. Initially this will 1. Okay. 1, 0 plus 1 is 1. Whole bar is 0. So immediately this will become 0. So this 0 will come. 0 plus 0 is 0. Whole bar is 1. Yes. Who is having less delay, that output will be changed first. That will affect the next gate simply. Maybe in between hazards may occur. Don't worry. I am saying about the final steady state. Aishwarya and Ganguly, now it is clear. If it is okay, otherwise I will explain it. Okay. Aishwarya and Ganguly, please comment. It is clear for you. Very good, very good. So let me explain now the condition when both the delays are same. Okay, so you are waiting for that also. Let me do that. Okay, so same story again. S equal to 0, R equal to 0. Steady state means final value. Priti, in between hazards we discussed now, it may change to 0 and come back to 1. So whatever you are getting at the final is called steady state. Okay. So now listen here. Practically, at least some little difference may be there. Even you made with same manufacturer, same beta value transistors, whatever you take, practically there will be some little propagation delay difference will be there compulsory between the two transistors. I mean two gates. Definitely, a little delay may be present. Is it okay what I am saying? But ideally, let me take if both the gates are having same delay. This is ideally possible. Practically, no. Is it clear? If TPD1 is equal to TPD2. Now, let me apply S equal to 0, R equal to 0. Now you analyze from any point your wish. Okay. Or because both should change at a time here. Will you accept it or not? Already these ones are present here. Both the gates should change at a time here because both of them are having same delay. So this fellow and this fellow, because I don't have two writers, I cannot write two at a time. I am writing one by one, but you understand these two will change at a time. Yes or no? This one will come here, one will come here. 0, 1 is 1 whole bar is 0. 0, 1 is 1 whole bar 0. So both fellows will become 0. Very good, as if you understand my language finally. Now, wait. Now this 0, 0 will come back. Now it will not stay here. It will come back or not? It will come back. And now it will be again 0, 0. Then what happens? 0 plus 0 is 0. Whole bar is 1. 0 plus 0 is whole bar is 1. Now this is a continuous process of 0, 0, 1, 1 and so on. Some kind of oscillatory response you will be getting. Okay, this is true when both the delays are same. So generally, we confine our analysis assuming our initial states are valid states, not invalid states. If you start with invalid states, it is possible. Okay, still it is invalid, but what's happening is oscillatory kind of response. It is definitely invalid. Okay, some kind of square wave generator or whatever. Okay. Now, bistable should be constant, Vasista. You can say it kind of astable multivibrator. So, is it clear? Some extra analysis required here. These two slides. This is not part of your final answers in the truth table. Okay. Useful means it is up to you whether you use it. If it is useful for you, you can use it. Okay. According to flip flop, it is not required. You can do this with simple one inverter. Now, why to do this much circuitry to do this job? Flip-flop should do my job. Okay, why is stable Abhinit? What happens here? We have discussed this in the basic. Whenever it is toggling, okay, I mean oscillatory response 0, 1, 0, 1, it is called no stable state. It is called astable multivibrator. So it is like you have a laptop, but you have a charging point. So laptop will give only charging. Will you accept? Laptop is working like a mobile charger. Yes, laptop can work like a mobile charger, but no one buy with 40,000, 50,000 for mobile charger, right? It can be done by simple charger. Similarly, simple inverter can do this job. Why to take this all this analysis here? Okay. So let's move further. I hope it is clear for you, crystal clear. But here, Asif, you are decoding me like anything. Whatever I am having in my mind, you are typing clearly. So your frequency is matching with me. We are synchronous with each other in digital language. It is network, we can say, as a resonance. Okay, let's go. So using our second friend, NAND gate. Okay, let's start. Let's start the analysis. Listen. Here you observe, I took S in the top, R in the bottom. S in the top, R in the bottom. So because it is my job again, I should get back your basics of NAND gate. Basics of NAND gate. Okay. For time being, I'm not speaking about clock, triggering, etc. Don't worry about them. We'll talk about it tomorrow. Okay. Today we are taking very basic part. What is triggering and all those stories will come. Yes, for NAND gate, if one of the input is 0, other friend can be anything, it will be 1. It is called disable input. Okay. I told this in the basics. Similarly, for the NAND gate, if one of the input is 1, other input is A, 1 into A is A whole bar. It will work like a inverter. Only these things should be in your mind, then you can play like anything. So let's start your play. So start with S0, R0. What is the disable input here? Keep it in your mind always. Fix karo. It should be in your mind. NAND gate disable input is 0. Here both are disable inputs, my dear friends. When both are disable inputs, what is the output? You should comment now. Other input means already existing values can be anything. It doesn't matter. What is the answer? One of the input 0, other can be anything. Your NAND gate output is 1. Okay, what is this? I am giving you small homework. Analyze if q bar equal to 1 initially with TPD1 greater than TPD2, TPD1 less than TPD2, and both equal. This analysis already just now I did now. What you should do for 9? Okay, this part I have already just now done. I don't want to do this again. Same thing. Can you do it? If you don't do, then you can ask me in the doubt session. This part just now we done for NOR gates, na same thing. Okay, so leave this part. Now tell me here, when S is 0, R is 0, you have accepted, everybody accepted, na? It is the simplest way to analyze. Nothing to worry. One of the input 0, other input can be anything, you get 1, 1. Whether initially 0, 1, 1, 0, you need not worry about it. No, here S is upper side only, Rishi. Very good. You are worrying about it from, I think, Little previously also you commented, I have seen but unable to answer. Don't worry. S is in the top, R in the bottom only. Okay, I will explain its reason also. Okay, just wait for some time. Shall I move further? Tell me, yaar. Yes, there is a difference. In the NOR, it is S bottom, R top. In the NAND, S top, R bottom. I will explain the reason if you wait for some time. Okay? Intentionally, I have taken, it is not a mistake. I have taken it with a reason only. I will explain that reason. Don't worry about it. So, shall I continue? For S equal to 0, R equal to 1. S equal to 0, R equal to 1. Is there any disable input? Please comment. Is there any disable input? Yes, where you have S. So what is your method? Other input means previously whatever you have, it doesn't matter for me, sir. Previously I don't care about the previous value. 0 plus 0 into anything is 0, whole bar is 1. Now this 1 will come because it is 1, it is an inverter. 1 bar will come here 0, or 1 into 1 is 1, whole bar is 0. Same gates, simple connection changes. See how it is helping us. So please understand here, don't care comes means what? It can be anything. Initially 0, 1 or 1, 0. Don't worry about it. It will always give you 1, 0. Okay. So this is what we call set condition. Right? Set condition. Set is coming for S equal to 0. I will explain everything. Don't worry. Okay. I made this intentionally only. Reason is there. There is a reason behind this. Okay. So when S is 0, R equal to 1, we did the analysis. Similarly, when S is 1, R equal to 0. Again, you start commenting any disable input. Nobody, please don't hesitate. You just keep commenting whenever you feel any difficulty, or also please actively involve in the class. Yes, R is having disable input, sir. So other input can be anything here, that is previous value can be anything. 0 plus anything is, so 0 into anything is 0, whole bar will be 1. This 1 will come here. Okay, because it is 1, it is inverter. 1 inversion will be 0. We call this as reset. When will we say it is reset? Whether it is initially 1, 0 or 0, 1, any case you should get the same answer. Okay, next. Last case. So this is your case when S equal to, what is that? 1, R equal to 1. Why NOR gate came here? I'm sorry. Sorry. Sushil, just wait. If you have any doubt, up to the end of the explanation. Okay, your friend came. So now please listen. Let me make S equal to 1, R equal to 1. So I make S equal to 1, R equal to 1. Is there any disable input, sir? There is no disable input here. And yet one of the input is 1, it will work like a inverter. So here, what is the meaning? It will work like a inverter. Or you can say because one of the input is 1, it is nothing but your this condition. You accepted? Right. Now see here. Now please listen. How to do this analysis? Let me complete this, then you ask your doubts, Saurav. Otherwise, it will deviate. Just wait for some time. So please listen here. Initially, please listen here. When both are ones, that is, there is no disable input. If you have disable input, we take the other input can be anything. That's why initial value doesn't matter there. Here, initial value doesn't matter because you have don't care. What does it mean? Initial value can be anything. Accepted? But here, no disable input. Na? Your initial value matters here. So suppose you analyze from any point. This 1 will come here. 1 into 1, how much? 1. Whole bar is how much? 0. This 0 will come here. 0 into 1 is 0. Whole bar is 1. Same way here also. This 0 will come here. Okay. So this 0. Okay. Then what happens? Inverter is 1. 1 will come. 1 inversion is. What does it mean? It can be 0, 1, 1, 0. You are getting same. We can say no change. So when do you give priority to the initial values? When there is no disable input. If you have disable input, blindly don't worry about initial conditions. Start analysis from disable, that will help you easily. Okay. So in this case, analyze if initial 0, 0 and TPD 1 not equal to TPD 2 and TPD 1 equal to TPD 2. Okay, so just wait, just wait. Here, because you have disable input, this is not a big homework. Okay, I can remove this because anyway it is invalid only. But this is a good homework. You should try. Yes, Abhinay, you should tell me. Now, any doubt you ask me. Your total SR, NAND and NOR latches is completed. So why we can't take Q bar 0? That's what I am thinking, na Bhargavi. I ask you to analyze this part. I have done that for NOR gates, na same way you try it for NAND gates. I took any one of the valid cases. If invalid case is taken, how to do it? I am asking. Homework. Any other doubt? Someone, Saurav, any doubt? Okay, happy. So now let's make this table and finish this job in the SR. qn plus 1 whole bar. Okay, this is what we call no change. Okay, or hold, yes, no change, hold condition. Here, what is the answer? 1 invalid. Okay, so this latch is called active low. Okay, so if you take a block diagram, why it is represented like this? Because when S is 0, please understand, when S is 0, it is doing set. When R is 0, it is doing reset. That is the reason we call it as a active low case. Now you understand that S top, R bottom reason. This is what we call active low case. Okay, when S is 0, it will give you set. When R is 0, it will do reset. That is, when the particular input is 0, it will do the set or reset. Don't understand this is inverter. It is just to indicate that they are active low cases. If you take one inverter at the S and R input, it will work like a same as NOR. That I will explain. Okay, is this clear? So NAND implementation is active low. Similarly, what is this? This one is active high. See, examiner block diagram he can give anyway. Block diagram he can give S top, bottom, R doesn't matter. But in the original internal structure, S should be in the down, R should be in the top. For the NOR implementation, S should be in the top and R should be in the bottom for the NAND implementation. Bubble is to tell you it is active low, not like it is inverter here. No inverter is there here. It is just to tell you these are active low circuits. Bubbles are shown to say that they are active low. When it is 0, it will do set. When it is 0, it will do reset. That is the meaning. Okay, if it is clear, your entire sequential circuits will be very clear. Now you are able to understand SR happily clearly. So let's move further. What is this? NAND gate. Okay, you want to convert this into NOR. It is cancels and this will give you NOR gate. NAND will work as a NOR gate. Okay, extra the inverters are required, right? Yes. But here today you are reading my mind. Depends on IV. IV means initial value, otherwise I'll write. Determine the Q when S equal to R, 0, R equal to 0. So let me start the poll. Deep, okay? Right. Wow, so many right answers. Very good. Very good, very good. Whenever I say very good, right answers percentage is decreasing. So finally, 45% right answer, 55% wrong answer. Who are the top 10? Sagar, Amitabh Ji, R.K. Singh, Ashish, Joe Matthews, Abhinay, Krishna, Hrithik. One of the input to the NAND gate 0. Don't worry about the other inputs here. 0 into anything is 0, whole bar is 1. Whatever may be the delays and all, never worry about it. It is a disable input. Then what about indeterminate? Indeterminate means you don't know what is the value. It is not same as invalid. Indeterminate means generally Okay, suppose S equal to 0, R equal to 0, we say generally it is invalid condition. Okay, it is not a valid because both will be 1 1. Yes or no? Invalid is different, indeterminate is different. Indeterminate means you don't know, okay, exactly what will be the output. You know here it is determinant but not a valid. Okay, don't confuse with these terminologies. Okay, so what is the right answer here is 1 only, because one of the input 0, blindly your answer is 1, no doubt. Yes, yes. That's why I keep that option. So let's move little further. Let's try one more question. Not past, I'm not talking. Examiner don't give like that. Even one. Previous gate question only. Just read. You want to hear me zoom? I don't think it is required. SR latch is made using TTL gates and all. 1 minute, 1 minute, 1 minute. In the question, printing mistake is there. It is a part of the question. Now read. An SR latch is made using TTL gates as shown in the figure. Here, reset inputs are provided so that you should be able to give zeros and ones. It is observed that circuit fails to work as desired. SR latch can be made functional. So why it is not working? You should troubleshoot, and then what is the required condition to be done? So let's start the poll. Get ready. So you don't need much time. So what's the right answer here? Understand one important part in this question is this. What is that important part, sir? It is a TTL logic gate. TTL means what? For TTL, floating input, we have discussed here when switch put is equal to 1. When switch closed, okay, then input is equal to 5 volts, which is again 1. So whether you close the switch, open the switch, these two lines are fixed to 1 volt. That is the problem here. One logic 1. That is the problem. So it may give it here 0 0. It is not your whether you close the switch or open the switch. Your inputs are not affecting your system here. Accepted or not? Forget whether you have this inverter is doing what jobs are and all those things. This table may not be same as what we discussed in the class. S may not be in the bottom, R may not be in the top. Don't worry about those things. That is a standard. Even the interchange, it is not a crime. It will do the job of the latch. Maybe you may not get exactly what is required in your old table, but it may be toggled and you will be getting that. But here, the problem is not NAND gate or NOR gate. Okay. What is that? TTL gates means total is TTL gates, man. As if an SR latch is implemented using TTL gates. Total circuit is made of TTL gates, not after NOT gate. Okay, don't decode your examiner wrongly. It will be very costly. All are TTL. Okay, no people. Using TTL gates, he made a latch. You please consider this is also part of a latch. It may be used to convert 1 into 0, or doesn't matter. Now what to do? Simply listen. What to do is replace this with a ground. Now what happens? If you replace this with the ground, what happens? Tell me. When you open the switch, it is 1. When switch, SW means switch. When switch is closed, it is ground. Ground means 0. Now it will do its job. You open it 1 1, close it 0 0, 1 open, 1 close, 0 1, 1 0. All things can be possible. So what is the required condition? What is the required condition? The 5 volts voltage source should be replaced by ground. I don't know why few people only able to answer it. Whether it is valid or not doesn't matter, Madhuri. Please understand here. 1 1 will give you 0 0. Whether it is valid or not doesn't matter. It is not changing here. That is our problem. Latch should read the inputs. Now you give 0 1, 1 0. You give anything. It is not changing. That is our problem. If condition is not TTL, then examiner don't give your question, man. Covered? Condition is not TTL. Why examiner will give that question? If we implement the C, what is C, man? Kubul? What is that C? You want to implement the circuit? It doesn't matter whether it is C here, simply whether it is NAND gate, NOR gate or XOR gate, inputs are constant. It will not do your job now. Whether it is NAND gate, NOR gate, inverter, okay, XOR gate also, no use because inputs are not changing. That is the main problem, right, Deep? So let's move further. So now, Mozart, you have taken wrongly. You take S in the bottom, R in the top. What happened today? From past 2-3 days, you are behaving differently. What happened? Already earlier also we talked to S, Aditya Max, Aditya Minter. Please see here, right? In the SR latch, whether you made it with NAND gate, NOR gate, you toggle S and R also, don't worry. You don't get the same truth table. SR latch is tables implementations. Even you take S and R, 0 is 0 0, na? It doesn't, you know this, right? Irrespective of the positions of S and R, these two lines will not change. They will not be same. For NOR gate, this is no change. This is invalid. For NAND gate, this is invalid. This is no change. They are not same. So next, it is having one invalid case in the truth table. Now, we can overcome these disadvantages by using SR flip-flop. So now by using flip-flop, actually not SR exactly, by using flip-flop. So we are moving to flip-flop. We are moving to flip-flop. So little next, okay, what we are going to discuss now is called flip-flop. So now firstly, I will discuss SR flip-flop using which gate you want, NAND gate or NOR gate? You like NAND? I will start with NAND. Both I will discuss. So whoever typed first, I am giving first in, first out. Start kiya Amitav ji. They are first in the queue. So I have little fancy today. Now let's do one thing. I want to change the theme. I got little bored with this white color thing. So SR flip-flop, good na, after so many days. Inversion property, background, while it is there. Now I use one new input. This is your control input called as clock. Okay, why clock is required, I will explain, don't worry. Why you can't see anything, man? Is it not visible, everybody? Please comment. Developer is not crazy like us, so he changed that color black into white. Okay, so let's do it. Where we are now, can you tell me what is this box? What is this box, friend? Tell me. Which latch? Which latch? You should say it is nothing but. Very good. That's it. SR 00011011. Just for quick revision, it is in. Now, for your easy understanding, what I will do is I will replace this figure with this figure. This is one. Done. So let's see how it will work. Okay. So for understanding purpose, so here three inputs are there. What are they? Someone asked me to use violet. Nothing is mentioned, then it is nothing only. Prakash, nothing is specified, then it is active high. Here you need not worry about active high and active low. Okay. So don't worry, just wait for some time. Okay. So clock S R Qn plus 1. It is a very simple one line understanding now. Okay, because we have already analyzed the earlier figure na, so here you need not give much effort. I will make the analysis very easy, simply like this. Just to see here. Anything, 0 into anything, what is the answer, man? 0 into anything is 0, whole bar is 1. So for SR NAND latch 1 is going. What is the answer? S and R. Originally S and R can be anything. Internally 1 will go. Internally 1 will go. This box already analyzed. Don't analyze again. Don't waste your time. So 1 will go. What is the answer? Right. So clock 0 may input can be anything, it will not read. This is the advantage here. Clock is like a control. When it is disabled, your input will not be read by the system. Some noise occurs, something occurs, it will not read the system. When clock is 1, now what happens? When clock is 1, what happens? Let's analyze it. When SR 0001 1011. Wait. When clock is 1 into anything, what is the answer? 1 into S is yes, NAND gate na S bar. 1 into R is R, NAND gate na R bar. So it is working like a, originally whatever you give, it will go inversion. Just read this table reverse. What is the reverse of this table? Qn 0 1 in value. You have accepted or not? When it is 0 0, it will do 1 1 job. When it is 0 1, it will do 1 0. When it is 1 0, it will do 0 1 job. When it is 1 1, it will do 0 0 job. So this is the easiest way to analyze it. Don't again analyze this part, everything. Don't end up with confusion. Once you are done with this, keep this in your memory. You keep your latch open. Okay, but one advantage with this memory and your memory are same. But this fellow is having one advantage compared to you. What is that advantage? They can delete. Hold is not advantage, man. Chaitanya, you have hold capability. That's why you are writing your GATE exam. Okay, this fellow is having capability to remove also, but you don't have that problem, that data, that option in your mind. You cannot remove ideally. Yes or no? Suppose you give 0, 1, it stored 1. Then you give 1, 0, it stored new data. It will delete the old. Okay, but our brain, your brain, you cannot delete. You cannot delete your breakups and all those things. If that is the rule, you will be very happy, I think. Okay. So let's move to the next one. Right. Well, what you told is right. Just I will give you that conclusion. Yes, invalid is there. That also we overcome. Please understand, Sushil. You have so many problems. One by one, we should solve. Don't accept all problems to be solved by this single person. How can he do it? He will solve one problem. Second problem will be solved by some other friend. One by one, step by step. Okay, just let me come. This is your RIB batch, and otherwise you follow other classes also. You watch them for practicing or revising like that. Only questions, not same. Some may be repeated. Some depends on the question type. Some may be repeated. Some may not be repeated. At least half maybe new questions. I may not take much same problems also. Okay, depending on their level. Same subject. Digital only. SR NOR latch. This is your Q10. NOR means not all gates are NOR gates. Box part will be NOR. The outside part can be anything, depends on my requirement. Here NAND will do my job. Here AND will do my job. Because it is active low, to cancel, convert active low into active high, I use this. Okay, so come here. Can I draw this figure with boxes? AND gate is there. Another AND gate is there. And in between we have one new friend, control, that is the clock. Everything, clock is a superior man. Shivagami is under the. So till now we have not used white color. Now let me use it. Change it. Okay. So when clock is 0, you just 0 means how much? Then so same truth table will come. Functionally, this will come. Answer same. Here don't care is anyway invalid. Whether it is 0, 0, whether it is 1, 1, don't worry about that. Maybe this cross and this cross may not be same, but we don't worry about that. That is anyway invalid. Invalid mental fellow can be anything. Right? Whether he is 0, 0 or 1, 1, no one mind about it. Okay, so you can understand in both the cases, the truth table is same. So now onwards, if I say flip flop, you need not get the doubt whether it is active high or active low, whether it is NAND gate or NOR gate. Don't worry about it. This is the standard for SR flip flop. Someone asked me earlier, sir, nothing specified what to do. This is the truth table now. Whether he specifies something or nothing, this is the only truth table of SR flip flop. Extra input you have. Now what I will do, please see, simply I draw the box like this. I can connect a thing. I can write this as S, this as. I am talking about this box internally, whether it is made with NAND or NOR, it doesn't matter for us. Is it okay, everybody? Originally, what is the internal circuit? You know. Okay. We just show by this block diagram. Now, yes, your S and R can be when clock is 1. Now still you have one problem. Who is that problem? Yes. In the block diagram, we generally show S in the top or in the bottom. So no need to worry whether it is internally NAND, NOR gate, all those things gone. You should remember this table. Only one problem still exists, as Sushil asked me. Still one, he is able to solve one problem, but not the second one. Second one will be solved by using JK flip-flop. So I will take a few more minutes to complete 2 parts of this, that is characteristic table and excitation table. Then we can end the class. Then tomorrow we start with the JK flip-flop. So let me complete the remaining part. Are you ready? So अभी black and white board, black board चल रहा है. So the next one we discuss is characteristic table of the flip-flop. Of SR flip-flop. So it contains 3 inputs S, R, Qn. Of the SR flip-flop, just tell me this part. When SR 0 0, very good. What happened, Asif? Qn. Similarly for 0 1, forget about Qn. For 0 1, what is the output? For 1 0, what is the output? For 1 1, it is invalid. Everybody understand this. Now characteristic table is very smooth for you. Okay, see here. When here during these two lines, your output same as previous value. What is the previous value here? Next also 0. Previous value here, next line so 0. What is the meaning of this table? Please understand the meaning of this table. My S and R are, these are my inputs. This is already existing. Then what is the output I will get? Is it clear? The answer? These two cases, irrespective of here SR 0 0. Already if you have 0 only. When SR is 1 0, whatever you have, you get 1 only. When it is 1 1, you don't worry. That is not required. Okay, Sushil, n plus 1. By using your, you can make 1 R bar Qn. Equation of per is valid for 0 0, 0 1, 1 0, but not 1 1. That is, SR should not be equal to 1. SR should be generally, this part already we discussed now. This equation we have derived is valid for 0 0, 0 1, 1 0, but not for 1 1. Okay, got it, Deep? Is this clear up to this? Is this clear up to this? This will tell you the characteristic equation. It's used, everything used in the design. We will use it in the design. Don't worry about it. Understand the concept basically first. So last part of the today's class is one leftover part is excitation table. So what is the mean? What it will tell you is if Q equal to X, then to get in the next state y can be 0 or 1, doesn't matter, it can be 0 or 1, it can be 0 or 1. What are the inputs? Now I told the meaning of the excitation table properly. If excitation means what? Input table. Okay, just a reverse of this characteristic. Characteristic will tell you if these are the inputs, this is the present state, what will you get? Excitation table. So reverse of the table means you should take it to be given to achieve the inputs. This is the present output. This is the output after applying the input. Okay. So what are the inputs I should apply to achieve this 0, 0? 0, 0 means what? I already have 0. Next also 0 only. Please wait. Please wait. Two ways, please listen. Two ways are there in the truth table. To get 0, what is the input? To get the 0 in the SR flip flop, one input is 0, 1. Second input is, this is one thing. Okay. And another is no change condition also there. Please listen. Please listen. Don't comment. Don't comment. Just listen. Present 0, next also 0. What does it mean? No change. No change means you can give 0, 0. Okay. It is a no change condition. You can achieve it by don't changing, by giving S and R 0, 0. Accepted or not? Tell me everybody. Those who are very new to this. Another way you achieve this is 0, 1. What does it mean? What does it mean? S should be 0. R can be either 0 or 1. No problem. What does the meaning of this X here? When S is 0, R is 0 or 1. Both the cases I am able to achieve this. Both the cases I am able to achieve this. Everybody, if you understand this, remaining is very easy. You can also say it is a reverse of characteristic table. Very good, very good. Just wait, just wait. So presently 0, I want 1. Presently 0, next I want 1. What to do? Presently 0, next I want 1. See here again. Again, just wait, just wait. If you want 1 in the output, go back to truth table. You should remember, if you want 1 in the output, what is the input to be applied? What is the input to be applied? What is the input to be applied? 1, 0. So presently 0, next I want 1. I can do only one possibility, 1, 0. Don't say 0, 0, sir, because it is not no change condition. It is changing now. You should not give 0, 0 here. You should give only one case. What is that? 1, 0. Now again, listen here. All possibilities we are analyzing. Presently 1, next you want 0. What to do? Everybody, presently 1, next you want 0. Whenever you want 0 in the output, you can give 0, 1. Here you should not give 0, 0. That's what I am saying. Why 0, 0 should not be given, sir? Because 0, 0 is to be given only when no change is required. Right, very good, very good. You are able to understand. Last case. Presently 1, next also 1. Now you observe it is a no change condition. It is not changing. And also whenever you want 1, you can achieve it by giving 1, 0 also. So two possibilities are there here. That is, it can be anything. It should be 0. Two cases, both the cases you should take. Both, all possibilities you should take. So finally, now you can make the table of this, what we call excitation table. As it is in table, let me write it in the table form. This is what we call excitation table of the SR flip-flop. Here, to remember easily, I give you one shortcut. You read like this: 0, 1, 0 cross. You read like this. It is also same. Just observation. Okay. Now wait. I told it is a characteristic table. Reverse is excitation table. Now, instead of doing this analysis, I will do that. Listen. Tell me here one thing. What is this first one? 0, 0. Just go back. In the table where you have this 0, 0. Qn 0, Qn plus 1 0. Two cases you got this. Spot them. What are your S and R? Tell me 0, 0, 0, 1. That's what I took now here. That's why it is 0 cross. Similarly, 1 minute, 1 minute. Suppose you want 0, 1. Go back to the table. Where you have 0, 1, 0, 1, 0, 1, 0, 1. Yes, here only. Nowhere else. You should take the input as 1, 0. So like that, from the characteristic table also you can obtain excitation table. Any method will give you same thing. 1 minute. Last line. The disadvantage with JK flip. Sorry, why JK? 1 triggering everything, master slave, everything will come. Add dedications. Okay. Some students have dedicated. I mean, good night, good night. So, what is your doubt, Deep? Please tell me what is your doubt. Yeah. Let me read. We don't say input is invalid. Okay. This condition output can be anything. Whether this output can be anything, it can be 0 or 1. Your SR flip flop performance will not change. We are worrying for SR flip flop only for this case because this is an invalid case, na. 1 case is invalid in the output. I mean, that case will not be required for us. I mean, it will not work properly for that. So for that, whether you take the output as 0 or 1, it doesn't affect your system performance. And also, when I write the characteristic equation, what I told, it is valid for 0, 0, 0, 1, 1, 0. It is not valid for 1, 1. I have specified here, that's why. This equation is valid for the inputs of 0, 0, 0, 1, 1, 0 only, because we are not analyzing 1, 1 in the SR flip flop. Is it clear, Deep? Good night. Good night, good night. Please 1 minute, 1 minute. Tomorrow before coming to the class, everybody remember this truth table, characteristic table, excitation table. Just revise this class, only PDF. Just revise it and come to the class. Just revise compulsory because these are the basics for understanding all the next topics. Okay. You tell me here. See the table. Deep. 1 minute here. Deep, please see here. If it is, you want to store the data here. You want to store, for example, please see. You want to store 0. What to do? Give 0, 1 in the input. It will store 0 in the output. Then you remove the clock or you make it 0, 0. Anything is okay. It will be in the no change. Na? No change means what? It will be in the 0 only. Class is up to August 8th. Similarly, if you give 1, 0, it will store 1 and make it disable the clock. It will keep it as it is. That's all. Thank you very much for the today's session. So we'll meet tomorrow. Yeah, message me in Facebook, Harshvardhan. Otherwise, in the Unacademy, I can help you. No problem. Saurav, first understand what is the meaning of the truth table, characteristic table, excitation table. I mean, how they came. Okay, what is the meaning? Where we use it, that we discussed in the counters. It will be helpful when you are making counters, flip-flop conversions, etc. Its application we will see maybe in tomorrow or day after tomorrow class. Just for timing, just understand what is the meaning of truth table, what is the meaning of characteristic and excitation table. That is enough. So thank you. Good night. We'll meet tomorrow same time. Preeti, what is your doubt? Please ask. Why to analyze Q here? 0, don't care. One of the input is 0, you need not worry. Whatever value here, 0 into anything is 0, whole bar is 1. Is Z na S equal to 0, R equal to 0. If this is 0, this input, second input doesn't matter for us. Is it clear, Priti? When SRR for NAND gate, one input is made 0. Why you are worrying the second input? Whatever may be the second input, he said S and R are 0. So you will get 0 bar 1. He asked only Q, na? Question is asked only Q, not Q bar. If asked Q bar, we'll write Q bar also. So last slide, please check it. You have one invalid state now, we can overcome that using JK flip-flop. That's all. Yes, because in the question he asked only Q, otherwise also generally output means Q unless he asked specifically. From last timing, your for 1 and 1, your output. So in your K-map, you have not considered these two. I mean, this K-map is, we don't know whether they are 0 or 1. We just take it as it once and we have made this table. So this is valid only for 0, 0, 0, 1, 1, 0. This equation need not be valid for 1, 1. That is when S is equal to 1, R equal to 1. Okay, according to this table, when S and 1 are equal to 1, you may get 1 in the output. But we are not sure because we have taken it as a don't care. Okay, because you don't know na. For NAND implementation, this cross may give you something. For NOR implementation, this cross may be giving something. So we are just taking it as we don't mind about it. So thank you all. Good night. We'll meet tomorrow.